Okay, now in the last day, we have discussed the basics of machine learning, and after the second day, we will be shifting for your customized way. Uh, I think you remember the things what we have done in the last day. We have discussed the basics, and we have categorized machine learning, the types of machine learning in the basement of amount of the supervision and also the production level. In the amount of the supervision, we have classified as supervised learning, unsupervised learning, semi-supervised learning, and the reinforcement learning. And the based on the production or the way of model training, we have categorized as batch learning and online learning. And today we will be discussing the third way of categorizing the machine learning types, that is instant-based learning and the model-based learning. And after that, we will be discussing what are the challenges when we are coming across when implementing the machine learning project. And also, what are the applications in ML, and also the machine learning development life cycle, and also the last part, data engineer versus data analyst versus data scientist versus data ML engineer. I think that is not that much needed for you, because this is for the basic level. That means the guys who want to get into the industry of this domain, they want to get that idea, but I will explain that thing also to you. But since you guys are more like after finishing your graduation, therefore I have to go this thing in a different way, because you can watch the same thing in the, you can watch the yesterday means like the Eastern, and not the Eastern time, the Western time, guys. I have you have the recording in the YouTube. You can go through that one. So I will do this thing in a different way, but covering up the same elements, but I will be doing this thing in a different way, or and also in a more advanced way. First of all, I want to show you now, when you are going into the research field, what are the skills you want to know when you want to develop your own startup related to this data science domain. What are the things you want to know? So I will quickly go to this East Angela list, that one. Okay, angel list. This angel list is something all machine learning guys has to follow. Okay, this angel list talent. By moving to this one, you can see now there are data scientists. Okay, there are some data scientists, and the data science startups. Okay, the data science startups and the product-based companies are available in the US. Okay, now we'll see what are the things they are asking. Now here senior data scientist, they are asking. We'll see, just go to the profile, senior data scientist, and they have given the something about their job and job profile. So I will briefly tell about this one. They are looking for a talented and driven data scientist to join the founding team. While you will begin as an individual contributor. In our ideal world, you will grow to become the team lead and the manager of the data science organization. Okay, what are the tasks? Our team is building the data platform to encompasses collection, processing, visualization, analyzing, anomaly detection, root cause, and predictive modeling for both qualitative and quantitative data from our hospital partners. That means this is like a healthcare company. And we'll see the build and deploy scalable algorithms, apply statistical analysis and machine learning to curated surgical data sets, medical device data, and operational workflow parameters. Acquire and apply domain knowledge of the product and software stack to identify and derive the solutions of data inconsistencies and improve model performance. Develop frameworks for data ingestion and processing. Okay, there are a lot of things they have mentioned. Okay, and for the qualification, they will be asking for a master degree or a PhD in data science. Okay, there's one qualification they are asking. Rather than this thing, you should have these sort of things. So 5 years of proven experience in data science, a strong background knowledge and practical experiences in probability statistics and AI/ML, outstanding track records of past projects related to the research and applications of data science, strong coding skills, including Python, experience with common tools for data storage and processing, like Spark, that means big data things. The Spark, Hadoop, Map, these things are related to the big data things. Okay, those are the main qualifications they are required. If you forget about this degree qualification, this degree qualification is something you have to somehow gain. Okay, you have to. It is more into the academy. But this one, 5 years of proven experience in data science, is that actually 5 years? No, that is not the actual 5 years. 5 years you in the data science or software engineering domain, you are showing this experience means it is the project experience. 5 year means you have to show the real way of having the experience by your project experience. Now, for a project, it will take some time to complete the start time and the end time. There is a time limitation for the one project. Like that way, you have to show 5 years of that experience. You can accelerate your ability according to your strengths. You can accelerate things. Okay, normally if one person is showing some kind of experiences, some kind of project experiences by 5 years, that means this is considered for a normal person. 5 years, by having several multitasking things he is doing with what are the things he is doing in these 5 years. But you guys can accelerate your skills and come up with this 5 year experience within like 2 or 3 years. Okay, 2 years. I think you can't do this thing by 1 year, but efficiently you can do this thing by 2 years. It means the required advanced project experience you have to show. Okay, we'll our ultimate aim is to show that. Okay, within 5 year experience, how do you show within 2 years? 2 years, how do you show those 5 years experience within 2 years? By showing your talent. Okay, so right. So that is one thing. Okay, like that way you can see what are the skills that they have asked. Okay, you can go this side, and if you want to build up a startup, okay, you can go to the available existing startups, and you can see what are the skills they are required. Right. Okay, we'll come to our slides and we'll continue that one. And after that, we'll come to this and do our researches according to that also. Right. Now today, we are going to discuss about this according to this agenda. First, we are going to discuss about instant-based learning versus model-based learning. Before that, I want to just recap about the last day things. Okay, last day we have discussed about the supervised learning and the unsupervised learning. These things, these are the common algorithms that we used in the supervised learning. You have to just remember these things, because we will go to these things, these level deeply. But before to move to the further things, you want to just have an idea about, now you want to do the model training in the data science. What we are doing, we are building a model, so that you want to have some knowledge about your algorithms. Okay, the one algorithm is the k nearest neighbor algorithm. We call simply it is k nearest neighbor. The linear regression, logistic regression, support vector machines, decision trees, and the random forest, also the neural networks. Those are the most common algorithms in the supervised learning. And guys, unsupervised learning, I told last day, in unsupervised learning, the how do you identify unsupervised learning? There is a way of identifying the difference between supervised learning and unsupervised learning. What is the difference? That is, guys, the unsupervised learning, there is no label data. You only group in those things. It is like a black box. Inside that box, there are some groups, but no labels. Okay, you can't, algorithm does not tell that this is this group. Okay, these are some groups, which has some kind of similarity. So this group has this pattern. Okay, like that, this some according to some patterns they have classified. We can't say classified. The word classified is not a correct word. Classified is supervised learning. So they have clustered, they have grouped, but they do not have labels. Okay, those things we call as unsupervised learning. There also we are using algorithms, K-means algorithm, DBs, the algorithms that we have mentioned here. Okay, those are, we can consider as unsupervised learning algorithm. And in the unsupervised learning, one of the most common thing is the clustering. Clustering means grouping. According to this way, it has been grouped. Okay, like that, if you like creating a blog, and if you want to identify how many visitors are coming to your blog, okay, then you can do you can run a clustering algorithm on top of your blog, and you can group the members. Okay, it is done here. Then something called the visualization algorithms, because if you want to do analysis, then what you want to do first, you want to have the coordinate axis. When you have more features, it will be difficult to identify the patterns. So you can do a feature reduction and get the 2 or 3 features. Okay, main 2 or 3 features, and you can identify the pattern here. You can visualize and identify. Right. Last day, I also discussed something called dimensional reduction. Dimension means the features. That means features means the inputs. If you consider a data set, what are the inputs there? Okay, I'll go there to show you what we call. Hi, Solomon. Good evening.
Yeah, hi.
Okay.
Sorry for being late. I just
That's
came
okay.
home.
That's okay.
Yeah.
We are going according to your way. Okay, your way, because otherwise you will be you can see the same thing available in the YouTube for the Western guys. So I think it's better to go according to your way. That's why I have planned this thing. So we will discuss now. Earlier, I have given some instructions to Jedri related to his startup and how to do a nice startup. and how do you implement the data science there according to that way. And also for your research also, I will give you some guidelines and we'll implement those things. Okay, right. So guys, again, welcome to this thing. Okay, dimensional reduction. Here we'll see, first of all, we'll see a data set. I'll move to the Kaggle. Okay, Kaggle is one of the very famous data set repository. That means a place which has store the data. Kaggle, how to spell Kaggle? Ski, yeah, Kaggle datasets. You can come to this Kaggle. You can have a account there. Here the datasets is there. Okay, then come to this repository. Okay, and then there here you can download large number of datasets. Those datasets are available freely here. So you can your dataset. As an example, these are some of the datasets that I have used for our purposes. The Bangalore house price data. That means if you want to go with the regression type problem, you can use these things. Okay, I will just take one of these things just to explain you about the things. Shall I have this one? Yes, you can download it from here. It is 200 kilobytes, not a big data set. And come here. Yeah, we'll extract this thing. Sorry. And this is the Bangalore house data. Okay, guys, see. Okay, now these are the features, guys. Okay, features. These are the available features. Area type. Okay, availability, local, location, size, society, square feet, bath, and okay, this is the price. Okay, now can you guys tell me how many features are available here? How many features are available, and how many labels are available? Oh, the label means the class, or label means the output. What is the output? First, just chat or just talk. What is the output here in this data set? What is the output that you're getting?
I think the output is price.
Yeah, output is the price. Okay. Then what are the features, the inputs? All of these things are features, isn't it? That means how many features? 1, 2, 3, 4, 5, 6. Yeah. And 7. This thing is 8. Okay. Okay. Now we are going to determine the prices of the house. We are going to predict the houses of the price. Sorry, the price of the houses. Now, according to this way, tell me a feature which is not that effect for the prices of the house. Now, this area type, availability, location, size, society, total square feet, and the bathroom, number of bathrooms, that one, and the balcony. Okay. From those things, tell me one feature which is not that relevant to this one. Okay, that means that is not that effect for the price. Any suggestion? So
I think society.
Yes, very good. Society. It is not that relevant to this one. So one thing you can do, you can remove that one. If it is not, if it is irrelevant, you can remove. Because if unnecessary feature is available here, what will happen? It will be giving a bad image to the output as well. If it is not that relevant, what will happen? If you can consider it like a garbage. If you insert a garbage, you will get output also as the garbage. So one thing is that one. But if you are not sure about that one, okay, there's this society also, it will give some kind of thing, some kind of effect. Then what you can do, you can reduce the dimensionality of that one. You can reduce the dimension. That means you can do a feature reduction of that one. That means now this location and the society you can combine. Okay. Yeah, normally the location is affected because if you are in a prime area, the price of the house is it is increased. So what you can do, you can combine these two features. Okay, you can combine these two features and get a single feature. Okay, that means when you do something like that, a number of features will be reduced. This thing we call it as the feature reduction. Okay, it is a very important when you deal with the machine learning problem, uh, getting the data set, and you want to remove the unnecessary data, or you have to do a dimensional reduction. Okay, we'll come back to that one again. Right. Important because if you reduce the features, there are two things can happen. You can uh, remove the effect from the unnecessary data. That is one thing. And also what you are doing now, when you remove, when you reduce the features, your machine learning data set will be reduced. And because of that, what will happen? It will run faster. It will run faster. Then we'll start to learn about what is this instance-based learning. Now, last day I have discussed about the model training methodology, or what we call the production methodology. There I have discussed about what is that, something called batch learning and the online learning. It is like this way. Model training is like teaching. Model training is like teaching, the way of teaching. And instant-based learning or the model-based learning, it is like learning. Okay, there is a similarity between teaching and the model training. And also there is a similarity between instant-based learning or the model-based learning with the way of your learning. Normally, when we are learning, there is a specific way of learning. If you practice for an examination, if you have the examination tomorrow and the supervisor or the lecturer tells that you will be getting this question, exactly this question, and this is the answer for this question. Normally that won't happen. But if just imagine if you are getting the question, not for the PhD or the MSc, just imagine your undergraduate degree for the final examination. The lecturer tells that, yeah, this is a specific question. Okay, you want to get the and the answer also for this one is this one. Okay, if it is happen like that, what is your way of studying that one? Tomorrow is the examination. What you are doing normally? You guys know these things. What you are doing, like just go to your undergraduate time and tell me what's the way of you are doing. How do you do that? How do you study for that thing? Are you going to understand the problem, or are you going to spend your time to understand the problem and understand the answer, or you are memorizing if it comes for the examination? Okay, guys, are you there?
Okay, to me, I would say both.
Both. Okay.
Depending on the kind of subjects, it would
Yeah,
demand
yeah.
maybe you understanding the concept, for example, math or like maybe anything related to math or understanding. You have to really understand the concept, the basic concept inside, so that at least when you're being given a problem set, you can be able to understand it and then like be
Okay.
able to get it. But you see, some questions are very straightforward, like let's say definitions and others. So that one there you have to memorize them. Yeah. So I think
Yes.
maybe for me I would say both. Yeah.
Yeah, good, good, good. That is the correct way of doing that one. But according to the majority, what do you feel like? Oh, no, no. Some guys, they want to actually understand the question and they want to face for the examination and they want to get good marks. That is the one way because they will get the real value of that. But the majority of the students, what they're doing, they want to just pass the examination. Is that so? Some guys, they want to just pass the examination. If they have given a ready-made question and the answer also is provided, but they're doing just without thinking about the problem, without understanding what is happening there, they want to somehow score the marks. Is that so? There are some guys like that.
Yeah. Yeah.
Yeah. So that is just a memorization. They will be following just a memorization. In the machine learning domain also, like there is something called the instance-based learning. They are what they are doing, just getting the idea, not getting the idea, just memorizing that one and comparison. It will compare with the similarity measures. As an example, okay, now see this thing. These are the available data points. These are the available data points, and these also consider about these things. This square, these things, and these triangle things are the available data points. And this square is a new instance or new data point. Okay. Now you want to identify to which cluster this will belong. Is that to this domain or that domain? So what uh, what will be the methodology then? What will be the learning methodology? What it does, it will compare the distance between these things and this one. That means the closer points. Closer points, it will check the distance. Now, what are the closer points? There are two triangles here. And also, if you consider about this boundary, there is a square here, there is a square here, and there is this is the new data point. These are the existing things. Just imagine these are the existing. Now, if you compare the distances, you can see this has shorter distances, and this distance is more. This is more. This is more. Therefore, it will come to a conclusion. Since the distance is less compared to this thing, so this square is, this should be belonging to this cluster. That means the triangle cluster. By using the comparison between the distance. Okay, that type of methodology we call as instant-based learning. Okay, just compare and get the idea. Okay, so we have explained it here. System learns example by heart. System learns examples by heart and generalize the new cases by comparing it with the similarities. By using some kind of a similarity measure, it will generalize the thing. The most common methodology is the distance measure. Okay, some algorithms, they will use this methodology, this instant-based learning methodology. One of the most common is earlier I told k nearest neighbor algorithm. KN. It is using this instant-based learning. You see, what is this model-based learning? Model-based learning is the methodology of Solomon. That means they will understand in a way, they will understand the problem. There is a specific framework to understand the thing. Okay. So model-based learning means you will find out some sort of mathematical function, some sort of common methodology. Okay, you will really understand long term wisely. You will understand and get the value of this one. Okay, so what they are doing, they are building a model to predict the generalization. Okay, not just comparing the similarities, not just comparing this one and that one, not like that. There is a certain model for learn the things. Okay, so what they have done, they have used a mathematical function. Yeah, this dashed line boundary is the mathematical function. Okay, according to algorithms, according to different algorithms, according to different problems, you this mathematical function will be different. Okay, so just a simple question here. So this type of boundary, it has classified these triangles and what is that? These squares. Now there is no similarity measure. Okay, if it is left side to this boundary, it is triangles. Right side to this boundary, it is squares. Like that way it has mentioned. Okay, see example. So I want to check, does money makes people happier? I want to see whether the money makes people happy. So, so I want to come across with the machine learning model for this one. So you can get the data from the data sets about the GDP, gross domestic product. Okay, per capita. Per capita means the gross domestic product. That means the total production of the country. That is called the gross domestic product. If you divide it by the total population of the country, we will call it as the GDP per capita. Okay, according to that one, the highest GDP is available for, I think, is that Switzerland. Okay, we'll just browse and see for our understanding. Highest GDP per capita 2022. It is Luxembourg. It is dollars this value. In the Singapore, Ireland, Qatar. Okay. I had like 2 years experience, the very past experience I have having. That means when I was in the school level, I got the idea like the Switzerland and the Sweden like the first. Now it has changed. Okay. We'll see what is the highest GDP. That should be USA or China, I think. We'll see highest GDP, not the per capita, highest GDP countries. Okay, it's the United States. The second is China, third is Japan, and the fourth is Germany. Now, why then the China GDP per capita is getting low? Because the population is very high here. Therefore, it will be getting the low value. Okay, and India also, they will be having a very high GDP, but since the population is high, you won't get the what we call the higher GDP per capita. If we consider about this thing, the 56 moros, you can see India is the fifth according to the what we call the highest GDP. But if you divide it by the population, okay, you can see the GDP per capita is like dollars 1,980 below than the Sri Lanka also, because of this high population. Okay, I think you got an idea. Okay, you got the idea. So United States, it has the highest GDP, but even though per capita is also, it is high, 59 something, but you can see this thing 80,290. What is that? That's it. Okay, because its population is less. Okay, right. Got an idea about that one. So what our focus is. Right now, I have considered about this past data set. This the GDP per capita versus the life's satisfaction. And I want to come across with a model to verify whether there is a relationship between money and the wealthiness. Okay, if I plot the graph according to this one, if I take a GDP per capita to the x-axis and y-axis the life satisfaction, I got some points like this way, like the random scattering. This blue color data points, random scattering. I got like that way. So guys, this is there is a name for this random scattering. You can see like there are some data points here and there. If you can see a data points somewhere like that way, we will call it as data noise. What is that word? Data noise. Data noise means you can't identify a certain pattern. There are some data points are randomly scattered. Okay, we call it as a data noise. Okay, but even though there is a data noise, you can see there is a slight increase. If you consider about this place and that place, you can see there is a slight increase. And also, if you try to draw a line of best fit, okay, according to these data points, you can see you will be getting like points like this way, red points. Okay, if you draw a line across these red points, you can see there is a straight line or the linear behavior. Okay, you can draw a linear line. Okay, straight line. You can draw a straight line to this one. Okay, if you just draw a straight line, that means that is your model. Okay, you I am not recommending to draw a straight line for this one because then some points are out of the straight line. But if you just consider that there is an increase in pattern, okay, there is an increase in pattern. I want to make a very simple model. Very simple model is the linear model. Okay, very simple model is the linear model. Okay, since there are only two features, guys, you can see here only two features are available. Okay, when there is only two features, that means you will be getting very simple model. That means what is the most simple model? That is the linear model. So you can draw a best fit line here. So then it is like y equals mx plus c way. So you can say y is the life satisfaction. This is life satisfaction and mx plus c. So x is the GDP per capita. M is the slope. Okay, we will get the parameter for that one. I will get it as theta 1. And theta naught is now this line crosses this y-axis. Okay, it is the intercept. It is theta naught. So life satisfaction equals theta naught plus theta 1 into GDP per capita. So this is our function. This is our mathematical function which explains the behavior between the GDP per capita and the life satisfaction. So guys, this is the model. So this is our model. Now you can change these parameters. Okay, you can change these parameters. If you are changing these parameters, we call a special name for this one. We call it as hyperparameter tuning. Tune in these parameters, and after that you can change the behavior of this straight line and get the best fit line. Determine the best model using the parameters. Okay, now you can change the parameter values and you will be getting like this way straight line, that way straight line, and this way straight line. Okay, so guys, so how do you get a straight line properly? Okay, there are some things you have to consider. Something called the utility function. We call another name for this one fitness function, and the other one is the cost function. The fitness function, it will measure how good your model is. How good your model is. We'll consider about that one. But we will be coming with two methodologies to determine the best fit model. One thing is how good your model is. We will determine it by the fitness function. And the other one is the most common for the linear type models, that will called as cost function. In cost functions, we will determine how bad your model is. How bad means, guys, Now consider these are the exact data points. Okay, exact data points. These are the exact data points. Okay, these are the training things, real examples. Okay, now that Hungary, something like that, these countries really existing in these points. Okay, so these blue points are the real values. What is the straight line? That is our model. Our model is not the exact thing. Our model is the expected thing. So guys, if you consider now, if this point and this point, this the point in this straight line is the expected value. Point here is the exact value. There is a slight difference. And here and there, you can see the big difference is there. Okay. Like that way, you can identify a clear difference between exact and the expected. We will call it as the cost value. Okay. If you want to get a more accurate value, the amount of this difference, exact versus the expected, the difference between exact value and the expected value should be minimized. Then only you will be getting more accurate model. Okay, that accurate model, we will call it as the line of best fit. Okay, so by having a line of best fit line, you can see a line like this. Okay, right. Now, I think, is that clear? Guys, is that clear about the cost function? Cost functions means you are getting the difference between exact and expected, and you are minimizing that one. Okay, by using the calculus, you will minimize. We will later discuss how do we get the value of the cost function. Now, did you get an idea about this line of best fit? Is it clear? How about you guys? Are these things clear? Yeah. Okay, we'll move to the challenges in ML. We'll move to the challenges in ML. Okay, these are the challenges that we are facing when we are implementing a machine learning type implementation. The first difficulty that we are facing is the data collection. Data collection is a tricky thing. You know that now I have done some surveys to get some data relevant to some kind of things, because I want to finalize by the recent survey that I have put in the LinkedIn. That was like prediction of the ability of gaining a fully funded scholarship. Prediction of ability of gaining a fully funded scholarship. Now, guys, you know that after the graduation, if you want to go for a PhD, or after the undergraduate degree, if you want to get a master thing, some universities, they offer fully funded scholarships with the stipend. So to achieve that one, so I want to check how many guys, the guys who have already obtained a PhD with the fully funded way. So by taking their features, the way, asking some questions from them, how did they have achieved that one? I have to figure out some columns, and after that, the guys who did not, the guys who are waiting for get the PhD, I can check about, I can identify a pattern and verify, predict whether these guys are getting a fully funded scholarship or not. So guys, when doing a survey for those things, also it is getting responses, okay, to collect the data. It is a very difficult task. Okay, so there are some methodologies to get the data, to collect the data in the industrial wisely. We will be discussing those things when we are doing a machine learning implementation. And there are something called the insufficient data. That means you do not have sufficient data to do the implementation. And also non-representative data, poor quality data, irrelevant features, overfitting, software integration. What are the challenges that you are facing when integrating the software and the deployment, and also how to discuss about the budget. So in the industry, guys, normally it will be difficult to do a field research and get the data, and it will be cost-wisely expensive if you do a survey and get the things. But you can see now there are large number of social medias. Okay, by using those social medias, we can get the data. Okay, there are two methods, and there are certain websites that we can get the data. There are two methods that we are using. One thing is called the API method. We will discuss what is this API method, but now here just understand to collect the data. One method that you can use is the API method, and other thing is the most common and the most prominent method. We call it as the web scraping method. Web scraping method. Okay. Now the next challenge is the insufficient data. Okay, just imagine a toddler, a baby, when he is how he is identify whether this is an apple or orange. Okay, if I just tell this is apple to a toddler, okay, in the next day or after 2-3 days, he will identify whether it is apple or not. Okay, but for a small scenario also, we have to provide many examples for a machine learning problem, because we have a lot of neurons, billions of neurons in our brain, so we can quickly identify something. But the machine learning domain is not like that, because we do not have super powerful machine learning models. We are trying to implement those things, but those things still in research type. Okay, so normally what will happen for a small scenario also, you have to provide many examples. But for a big scenario like image classification or a voice recognition, you want to provide millions of examples. Then only it will identify and it will predict the outcome accurately. So regarding this one, Microsoft has done a research. What they have done, they have identified best algorithm for certain scenario. Okay, best algorithm for certain scenario, and they wanted to check, okay, the relationship between number of data or the records, number of data versus the best algorithm. Okay, number of data, and what will be more prominent, is that the amount of data or the best algorithm. Okay, now they have checked, they have taken the better algorithms and also some kind of average algorithms, and for better algorithms they have provided a low number of data, and for the average algorithms they have provided more data, and after that they have got a result like this way. Okay, according to this thing, they have figured out when there are more data, okay, when there are more data, the accuracy will be increased. So as a conclusion, you can say when there are data versus algorithm, if you consider data versus algorithm, the data will be the prominent thing. Okay, even if you are having average level algorithm, and if you are having more data, that means your accuracy will be increased. And non-representative training data, non-representative training data. Now guys, okay, consider about the previous example about that money makes happier. Okay, here some points that I haven't checked for my account. Okay, Norway, Switzerland, and Luxembourg. These three luxury countries I haven't taken for my account. Okay, Okay, and that means this only these blue points were available in my data set. I didn't take this thing for my data sets. These things are not available in my data set. Because of that, I got the function like this way, this dotted line I got. But if I take these things also for my account, I will be getting this type of line of best fit. That means if you are having some data points which are not represented, then your accuracy will be different. Okay, that means these things we can consider as non-representative training data. These things are not available. If it is available, what will happen? Your model will be different. Okay, that means non-represent. If you are having some kind of non-representative thing, okay, your accuracy will be different. When you are getting a sample, you have to have a sample which is representing more things, more domains, okay, according to your sample. Right. With that thing, we will consider about the sample noise versus sample bias. Sorry. Sample noise means, guys, when your data set is very small, okay, the availability of non-representative data. When you are having a small data set, and if there are some non-representative data, we can consider it as a sample noise. Okay, sample noise does not provide the accurate result, accurate generalization. Okay, sample noise. Small data set, even it is a small data set, you are having non-representative data. That means it is like this way. If I consider about the uh, survey, I want to check uh, FIFA World Cup. I want to get an idea about the FIFA World Cup, the next FIFA World Cup, Football World Cup, who will win the next Football World Cup. I will do the survey in only in Eastern countries. Okay, Eastern countries and uh, uh, some uh, some particular domain. I will get a sample from several Eastern countries and get the idea. They will it is not what we call they will give a idea only related to their perspectives. Okay, there are some non-representative data because why? They are in this domain also, in that Eastern domain also, there are particular parties. Now wealthy people are there, poor people are there. If I do not represent in those people, that means we can't get an idea. And also, if I ask the questions from the rugger guys or the cricket guys, they do not have a proper idea about the football. Okay, so those things means non-representative data. Okay, even now this sample bias means even I have taken a large data set. Also, the it also do not represent the whole thing. Whole thing. If it even if I'm having a very large data set, okay, yeah, then also it is biased to something. We will call it as a sample bias. One good example for this one is the American election. Those days, 1936 American election. Roosevelt and the Landon were the elected politicians for that election. And Literary Digest, this magazine has done a survey. Those days we didn't have what we call email facilities or this type of online facilities. What they have done, the posted mails and got the answers, responses. According to those responses, a very large data set they have got. According to that thing, they have concluded that Landon will be win. He will be won by 56%. But actual result was Roosevelt won by 62%. The reason was the many of the responses were biased to land. That's why they have got the wrong result. So we can consider it as a sample bias. Their result is biased to some. Their survey is biased to some. Then the poor quality data. Okay, this part is very important when we are doing a data engineering task. There are some domains in the data science. The first phase part is called as the data engineering parts. There only we will collect the data, and also we want to clean the data, because the data is in very different formats. We are getting the data from very different resources. Okay, Excel, JSON files, and some kind of databases, non-SQL databases, SQL databases, okay, text files, image files, different data formats. Okay, there can be some missing values also. Okay, there are some outliers will be available. So what you want to do, if there are like only 5% is available in your column, you can remove that column, because only 5% is available, 95% is not available. Okay, if you miss only very small things, you can get you can fill up those records by using median, mode, or average value. Okay, and also you can remove the outline. Irrelevant features, in some cases you will be having some irrelevant features. Okay, that means I told like garbage in, you will be getting garbage out. So if there are some irrelevant features, you can do some a technique called the feature engineering. What we are doing in the feature engineering, if there is a very much unrelevant feature, you can remove that one, or you can use the dimensional reduction. That means by using principal component analysis, you can reduce the dimensionality. Or if you want to have a new feature which is most relevant to this data set, you can create a new feature. Okay, by considering those three things: remove, reducing, creating. Remove, reducing, creating. That thing we call as the what we call feature engineering. Okay, we call it as a feature engineering. Feature engineering consists of three things: feature selection. That means you have to have only most important features, feature selection. Then is the feature extraction, combining features and get a single thing. And the third thing is creating new feature. Okay, then is overfitting. Okay, right now you guys in USA, if you have come to Asian country, for just visit or see the sceneries, and yeah, now if you want to go to some kind of place, some kind of beautiful place, you got a tuk-tuk or the three-wheeler. Okay, the taxi, you got a taxi, and you are going from that one. And like in Sri Lanka, the currency is the rupees. Okay, normally these things, because of the crisis, the fuel value is increased now, therefore the prices are a little bit high. But normally for a small distance, it will take like 100 rupees. 100 rupees means like one-third of a dollar, just 0.33 dollars. Okay, so you want to spend that one, but maybe there is a foreigner, by seeing like by your appearance, you're a foreigner, they can charge more. Like they will ask like 5,000 rupees from you, perhaps. Okay, perhaps 5,000 rupees. It will be like, then what's that? Like it is like $15. Actual charge is $0.33, but they have charged $15. So that you got disappointed. After that, you come to a conclusion called all taxi drivers are thieves. All taxi drivers are thieves. That means you have come to a generalization called all taxi drivers are thieves. But is that true? There are some taxi drivers are very much genuine. Okay, very genuine people, very hospitable people available. But you have come to a conclusion called all taxi drivers are thieves. That is called, guys, overfitting. That means it is valid for your exam. What you have experienced, it is true. What you have experienced, it is true. But it does not tell the generalization. But it does not generalize fact. Okay. According to your example that you have experienced, it is true. But it is not true for all. That type of thing, we call it as overfitting. As an example, these are some data points. Okay, these are some data points. Our model is going through all the training data. Our model is going through all the data points. You can say this curve, this is a curvy model, and it is going through all the data points. So we can say it's a very well valid for this training data. But for new data, if there are new data, if it is for the new data, you are not getting a correct value. You are getting a very low accuracy. So if that thing is happening, we consider it as a overfitting. Overfitting means simply it performs well on the training data, but it does not generalize well. Remember what is that? It does well for the training data, but it does not well for the new data points, or it does not generalize well. Remember, taxi driver example. Okay, why this overfitting is happening? When you are having a very complex model, you can see like this type of curvy model, complex model. When you are having a complex model, and if you are having a high number of features, if we are having high number of features, and also if you are having a very complex model, you will come across with this problem called the overfitting. Okay, how do you lower the overfitting? You can come across with low features and very simple model, like a linear model. If you come across instead of this thing, if you come across with a linear model, you can reduce the overfitness. And also you want to get more training data, because since it has gone through all the training data points, you can have more training data set. Okay, having more data set, having a simpler model, okay, and having low number of features, you can reduce the overfitness. Reducing of the overfitness is called the regularization. Okay, reducing of the overfitness, we can consider it as the regularization. Hyperparameter thing I told, hyperparameter means there are some parameters in your model. You can assign some values for the parameter, and after that you can tune the thing. We can consider it as a hyperparameter tuning. Okay, underfitting means it is just opposite of the overfitting. Just opposite of the overfitting. Okay, what we have happened in the overfitting, guys? That means it has gone through all the training data points. Okay. Underfitting means even you are having this type of points, it does not go many of the points. Now here it has gone through all the data points. If you are getting a straight line, which does not go through all the data points, only go across the few data points. When it is going through few data points, we call it as underfitting. Okay, what is this difference? Overfitting, you have seen that it is a complex model. Okay. Underfitting, you are having a more simpler model. You are having a more simpler model. Then you are getting this underfitting. So how do you overcome the underfitting? You have to have a complex model for that. And also underfitting happens when you are having a very less number of features. Now what you can do, you can have more number of features. Because selecting more powerful model, feeding better features. Okay, that means you are having more features, reducing the constraints on the model, reducing the regularization parameter. Now, the parameter value, that is also affecting that. So that parameter value you can reduce. This thing also to identify the overfitting. If the training error is low, that means you are getting a very low error for the training and getting high error for the generalization, that is overfitting. Okay, in some cases for the accuracy, you will be getting 100% accuracy. 100% accuracy. That means it is very well suited for the training. That's why you are getting 100% accuracy. Remember, guys, if you are getting 100% accuracy, that means your model is overfitting. Okay, in your scenario, if you get a 100% accuracy, normally machine learning models, you can't get 100% accuracy. If you get 100% accuracy, remember that your model is overfitting. Right. Okay, now this overfitting. I told several ways. Okay. Another way of reducing this overfitting is you are having a validation set. Validation set means now you are having a training set. You can subdivide this training set and take one part of this training set and keep it somewhere. We call this set as a validation set. After training those things, you can test it with that validation. Okay. Another problem that you are coming when you are doing the machine learning things, that is software integration. Now you are implementing this software, what we call machine learning model, to a one particular platform. It might be Linux, it might be Mac or Windows. Okay, when you are implementing this now, after creating this one, you want to integrate it to a particular platform. Okay, you want to have a more generalized platform or doing that thing. It will be a tricky thing. Okay, you want to follow certain things for that one, so it is also a challenge. And also when you are releasing this to the production, you have to use batch learning or the online learning. Okay, the batch learning is easy, but for online learning it will be somewhat difficult task. So that is also a challenge. And also the cost. Cost is not the exact cost what you are expecting at the beginning level. Okay, you will be getting various things as the cost. Some kind when collecting data also, you will be getting unexpected cost. Okay, and when pre-processing and the stuff also, you will be getting a cost which is unexpectedly, and integrating the things also, you are getting a cost. So cost is also a challenge, because you want to give a value for the product. Okay, that is determined by your cost. Right, guys, then applications in machine learning. Okay, normally machine learning is used for several domains, for your research purposes, your startups. But when you are implementing something for your startup, normally the two business domains we are discussing, one thing is the B2C. B2C means business to communication. That means you have a product, you are releasing it to the customers. Okay, that is a B2C. Okay, it is normally you are having thousands of applications related to B2C. But here I want to discuss some advanced thing, that is B2B. That means business to business communication. In the business communication, you having these things: retail, that means the supermarket things; transportation, manufacturing, banking, social media, and the space exploration, and the medical. Mainly, I will consider about these 5 things. Okay, when you consider about the retail, okay, now in supermarkets, you all have owned supermarket, and when you go for a supermarket, the supermarket guys, they have to identify now when there is a festival is coming, the Christmas is coming. Okay, what are the goods you have to have you have to stock ready? What are the things what are the things you have to stock up? Okay, now you do not want to stock up all the things. Okay, to get the idea about what should be stocked up, you have to think about the past records. Okay, past few years records. By considering those things, you can predict these things should be stocked up. Okay, so that you have to use machine learning. And then have you wondered why your retail shops are taking your phone number? You guys may think like they are taking the phone number for just an imaginary case. Not like that. They are taking your phone number, make a profile on you. Now you are doing shopping on one supermarket. After that, you have gone to your hospital or any function or any other thing. Okay, or you are visiting to another country. Okay, but when you are giving the your phone number to the airport, you are giving the phone number there. Okay, when you are giving the phone number, this you are using smartphones. They are taking your metadata. Metadata means not your in-depth data. That means your metadata means data about the data. By having the metadata, you can get an idea about your behavioral patterns. Your behavioral patterns. So why they are storing your phone number? Then they can get the idea about how your behaviors, how your buying cycle. According to that, if they have bought a new product, just imagine like a beauty salon thing. Okay, if you have gone to like wedding, something like that way, okay, that is also come to your profile. Okay, then they will identify, they will want this one. So we can promote only these people, this product, we will promote only this one. Then the cost will be reduced for them. Okay, that's why they will take their phone number. And this entire process is a machine learning process. And when you want to get a loan, okay, from a bank or financial institution, what they are doing, the first thing is doing, they will take your documents, bank statements, all of things. Okay, when you want to do a startup, and if you want to have some capital, okay, they will check, they will ask for the documentation, and what they will do, they do not check it manually at the first time. The earlier days they have checked manually, but nowadays what they are doing, the whole thing is under the machine learning process. First, what's that? It will be first it will be documented, okay, in Excel sheet or some kind of file. Okay, the data entry guy will enter the data, and that data is sent to the machine learning model. What the machine learning model task is, the model will compare your data with the previous defaulters, loan defaulters, that means who did not pay the loan, and check what is the similarity index. If that similarity index is more than 70%, they will understand this guy does not pay the loan. Okay, it will rejected by the machine learning model. Then you are not going for the manual process because your thing is rejected. Consider that your similarity index is like 20% or low. Then it will be accepted by the machine learning model. Then you will be going to the second phase. That means the manual checking, and that is the credit officer will check that one. And after that, they will allow for the loan. That is one thing. And also some kind of promotions also by considering a target audience, they will use the machine learning. Transportation. I think you guys used Uber. In US also, you are using Uber. Is that so, guys? Are you using Uber? Are there? For your transportation, taxis, are you using Uber? Are you there?
Yeah, sometimes.
Okay, right. How is the Uber? Uber means it is like a cars you are using, or the what are the things you are using? Here mainly we are using like three-wheelers. For you guys, cars. Is that cars? Uber taxis means, are those cars or vans? So the taxis means what? Hello, Jedri?
What was it? Cars?
Cars. That's cars. Now, what is the normal price for like 1 kilometer distance? What is their normal way?
Uh, maybe like 6 miles.
6 miles. How is the price for that?
Could be like $20.
$20. Okay, so 6 months, 6 miles, it is like $20, right? So guys, now you have the Uber app, and also in the driver side, they will be having this type of interface. Okay, guys, what is this 3.2x like that? These means the peak things, peak level. Now the peak level means now your early morning time. Early morning is like now 6:30 to 9 a.m. Okay, 6:30 to 9 a.m. That is their peak hours. Okay, peak hours. Because many people are using Uber at that duration. Okay, then Uber will pay more to these drivers at duration. Okay, how they pay more to these drivers? Because they have a demand. That means a lot of guys are using Uber. Because of that, they have increased the amount that they are taking from the customers. Okay, customers has to pay more, then driver getting more from that one. Because of that, because the supply, the demand is more at that peak time, and according to that, what will happen? They will do a supply because they are getting a more revenue. Because of that, it is now the supply and demand will be balanced. Okay, that thing is happening using a machine learning model. Okay, how the prices are increased. Okay, how the prices is calculated. All these things are happening under a machine learning model. So use of the machine learning in the transportation sector. And the manufacturing of the Tesla cars. Okay, normally the Tesla cars, they are manufacturing in a what we call a methodical way. First of all, you have to pay the whole payment before, like, I don't know the exact time, like 6 months prior to the delivery, you want to pay them all. Okay, then you are going with an agreement, and after that only they will start to manufacture the things. Okay, now they are using these type of robotic arms, okay, to host the engines and the other accessories. Okay, what will happen if there is a failure of these type of robo arms? If there is a failure of these robo arms, okay, the manufacturing process will be delayed. Okay, so if it is getting delayed, the customer will be unsatisfied. And unsatisfied, it is not good for the company. So how do we minimize this one? They will be behind the Internet of Things sensor. IoT device is available here. By using that IoT device, it can detect what kind of problems will arise at the future for this robotic arm. What kind of failures, what kind of tracks will be available. Okay, so they can pre-ready for that one. Okay, we can consider it as the pre-maintenance prediction. Okay, so they can identify after 2 months there will be a failure in this robo arm. Because of that, we have to be ready. Okay, and we have to do the maintenance part. They will identify that that whole process is under the machine learning. We call it as predictive maintenance. And the consumer internet. Consumer internet. Now you guys know how the YouTube is earning, but how this Twitter is earning. Twitter is earning. It is happening something called the semantic analysis. this semantic analysis is using natural language processing, NLP. Okay, a small example I can provide you. Now, you know that all you guys, okay, if you do not have a Twitter account, you should have a Twitter account, guys, okay? Because if you want to, like a person who wants to do a startup, like Jedri. Jedri, do you have a Twitter account?
Oh, no, I don't have Twitter.
Okay, it's better to have a Twitter account because when you want to do a startup, it's better to have a Twitter account because that domain. Now the Facebook normally using the normal general people.
What's wrong, baby?
LinkedIn
What's wrong? Is
used by
okay?
yeah.
Oh, my
Did you
little
tell something?
puppy. Oh, sorry, my puppy.
Okay. Instagram will be used by, that is also normal general people for their promoting their goods. Now this the Twitter means it is the above the average people they are using, like the people in the giants of the business industries, the startup people. Okay, it's a different type of domain. Okay, then what they are doing, like the Facebook, we will be using like and the things. Here, what's that? Tweeting. Now, if there is some kind of like political propaganda, just an example, consider when there's a political propaganda. Now the people are commenting and tweeting, and you can see there is a something like there is a proof for that people. Okay, now Twitter, what can do? They can do a small survey. They can do a poll and get the feedback from those guys. Then what that Twitter can tell for the investors. Now the people who want to invest in the stock market, they can get that survey result, and after that, by using semantic analysis, they can consider, okay, this time this political party has a high value, therefore stock market, you know that there is a correlation between the stock market and the political environment. Always there is a relationship like that way. Okay, when the what is that? The republic has some more power. Some kind of stocks will be decreasing, and some kind of stocks will be increased. Okay, the other party also like that. So by taking that result, they can give a idea for the investor is these prices will be going down. It is happening like that. So since Twitter is providing that result, okay, some kind of revenue is passed to the Twitter. That is just an example, not like the propaganda of the politics. The other way also, there are several things. Okay, according to that, they can generate the revenue. This whole thing is happening under the machine learning. Okay, the most important thing, machine learning development lifecycle. Machine learning development lifecycle. That means it is a set of guidelines which allow you to start a machine learning project from very scratch to the end. That means to the deployment phase. Okay, we'll see what are the main elements there. There are 9 steps. First of all, frame the problem. Okay, we'll see what are these 9. Frame the problem, gathering the data pre-processing, something called exploratory data analysis, feature engineering and selection, model training, and the model deployment, testing, and the optimizing. Okay, we'll see what is this framing the problem. Okay, guys. Again, we'll go to a startup question. Okay, we'll go. We'll write this one from here. I will type. List. again see here. I will get this one. No. Here. We'll see this one. Now here, okay, according to this company, what they want to do: exploring and analyzing large data sets, programming in large scale of Python, building successful and those things. We'll see what is their domain. The citizens will join the forefront of our data product journey to develop solutions delivering exceptional customer experience in both EXO participants and interval clients. The role will help the organization navigate the future with confidence by tapping into the power of advanced analytics, scalable decision making, and leverage the power of AI/ML to further power EXO's hypergrowth. They did not provide the idea about what is their domain. Okay, we'll take another example. What about this? I think this is good. Hospital. Make sense of complex electronic health report. That means this is like a hospital domain. Okay, hospital domain. Healthcare domain. Okay. Now guys, where is this? Training set is this one. Yes. Now, when you are framing about the healthcare domain, okay, to provide the AI solution for that domain, first of all, you want to ask at least these 10 questions. What are the questions you want to ask? What exactly is the problem? What is the problem? What is the available problem here? Okay. Now, when you want to do a startup, okay, if you want to integrate machine learning for that one, okay, you want to first finalize, is there a problem existing for me? Is there a problem? And what is that problem? Okay, what is that problem? You want to well define that one. You want to write it clearly, concisely. You want to write that problem properly. Okay. Without understanding the problem, you can't do anything. Framing the problem. What exactly is the problem? Then how do you solve it? Do you want machine learning for this one? Okay. Do you want machine learning for this one? How do we solve this one? Okay. If you want machine learning, why we are using machine learning? Will the cost reduce for that one? Will the performance increase for that one? By that one? And how do you solve? How, if it is machine learning, what sort of machine learning domain? Might be it is natural language processing. Might be it is deep learning. Might be it is computer vision. Okay. Something. What is that? Okay. How do you solve that? Might be it is brain computer interface. Who are the customers? Now, ultimately, what I want to do, I want to generate profits. So, who are my customers? Okay. How much will it cost? What will be the cost for that? Amount of the team. How many members should I have? Can I do only by me? Okay. That means sole property I can do. Or do I want to hire somebody? Okay. How is the amount of team? And now you are releasing a product. What should be the appearance of the product? Customer satisfaction is done mainly by the UI and the UX. Okay. Customer does not want the high complicated products. They want to have the features. Right? So how will be the appearance? Okay, then the technical ability. Supervised or unsupervised learning, online or batch mode. Okay, what type of algorithms? And also now the machine learning data engineers, they want to identify how do we get the data. So data gathering, I told that you can use the API method And also you can use the web scraping method. And also when need from a larger databases, what we call the big data. First of all, you want to have the historical data. To do the machine learning, you can't have the transaction data. Now that means this dynamic data. By having dynamic data, you can't identify the patterns. You want to have the historical data. That means this data has to be stored in a particular place for some time. Those things we call the historical data. We say we are storing those things as in a data warehouse. Data warehouse means it is a storage. You are taking data from the databases and clean the data and doing some reprocessing, and stored. We call that part is the engineering part, data engineering part, and stored in a historical data set. We call it as the data warehouse. From that data warehousing, you can fetch the data. And if you are using big data, we use something called Spark clusters. By using those Spark clusters, you can fetch the data. And the data processing. Now, I told you will be having different types of formats. Data will be in different types. There are some structural irrelevance, missing data, outliers, noise. Okay, you want to remove those things. We call that phase is the data preprocessing stage. In exploratory data analysis, what is this thing? Exploratory data analysis means, guys, you have to identify what is the relationship between your data. If you are having features, your input, okay? What is the relationship between this feature? Okay, you are having some data, okay? You can consider those data in that column, and you can take the mean value, mode value, standard deviation, even you can identify a pattern there. And after that, you can take 2 by 2, one column and another column. And after that, you can figure out what is the relationship. After that, multi-classes, you can figure out the things. After that, you can identify a strong relationship between input and the output. Okay, that thing we call as exploratory data analysis. There we can use the visualization techniques. Okay, after that you can identify. And also by this exploratory data analysis, we can have a balanced data. In some cases, our data, it will be having imbalance, like in the cat dog classification. If we have more images in cat and low images in dog, means it is an imbalance. You have to have balanced data. Then the feature engineering. I told like feature engineering, what we are doing, we are reducing the columns, and also we are creating new columns, removing columns if it is unnecessary. That thing is called the feature engineering. Now here what you want to do, you want to identify the best suited algorithm. Okay, best suited algorithm. To identify the best suited algorithm, there are some metrics, performance metrics are available. According to different types of algorithm, different metrics are available. According to that, you want to verify what is the most suitable algorithm for your domain. That is called model training. After that, you can train the model and get the accuracy. Then the model deployment. After creating the model, you can put it to a pickle file. Okay. Then you can generate the API. Okay. This pickle file, then it will generate something called the JSON file. Okay. Now, when you are inserting the data, user is inserting the data to a form, it will store in a server, and using a Python app, you can provide the API. Okay. This whole process I will be explaining when we are doing a end-to-end implementation in the next day. Next day, we will be doing a machine learning project. Start to end machine learning project in a very simple way. I will be explaining and doing. So the next day is very important, guy. Okay. There I will be explaining what is this model deployment thing. After that, what is that? You want to test the thing. We are using a beta testing. What do you call this beta testing, guys? Beta testing means after finishing your product, You will release it to a trustworthy community to get the feedback, whether it is good or bad. Okay, after that, by getting those feedback, you can do the optimization. You can, if there are some errors, you can uh, give the remedies for those things. Okay, you can have a model backup, data backup, load balancing, something called free training. You can retrain the model. Okay, and you can optimize. Okay, that is why what is this data engineer, data analyst, and the data scientist and the ML engineer, because these are several job roles in the data science domain. Okay, the first part is the data engineering part. The data engineering job role is the data collection. Scrape the data from different given sources and build up a data warehouse. Okay. Build in the data pipelines. Thus, the data pipeline means there is a sequence of getting the data and storing in the data warehouse. That is the whole process. We call it as a data pipeline. What are the skills you required for a data engineer? Okay, you want to have the programming knowledge like this Java, Python, R skill. Always, even it is a data engineering or data science or ML engineering, you have to have the knowledge of Python. Okay, so if you do not have the basic Python knowledge, I thought of developing your Python skills also. Okay, that means I will make a separate the lengthy video, step-by-step explaining about the necessary Python skills for a data scientist. You can just go through that one and learn your brush up Python things, because without Python you can't do the data science task. Okay, the data engineering and the data science, ML engineering, anything you want to have the data, this Python knowledge. You know, for data engineering, specifically Java, R, Scala, all those things needed. At least Python knowledge you want to have. Advanced database management system knowledge also you want to have for a data engineer. Data engineer means the person who is handling with the data in the initial phase of the data science project. Something called the distributed systems and also the cloud platforms knowledge. The data analyst means the person who is after the data engineering phase. The next person is the data analyst. What he is doing the visualizing things and identify the patterns. He's identifying the patterns. Okay, he's identifying the patterns. Okay, so in order to identify the patterns, he has to have the knowledge of the statistical programming, and also should have a creative knowledge and the analytical knowledge and knowledge of the SQL, and he has to visualize the thing. Now, this person is the person who is explaining what is the insights to the other people or the stakeholders. He's explaining this. So he should have the good communication skills, storytelling ability. Okay, and respect to this one, there is another person called the business analyst. He also doing the same task, but the business analysis is like a more managerial task, managerial job role. This is more engineering job role. Data scientist means the person who is handling the heart of the domain. He's a person who is having more statistical knowledge than the software engineer, and more what we call software engineering knowledge than what we call statistician. Okay, normally some people can argue what is the difference between data scientist and a mathematician. What is the difference between data scientist and a statistician? Okay, this person has more what we call software engineering knowledge compared to statistician. Mathematical knowledge and the statistician mathematical knowledge is comparatively similar, but this person has the more software engineering domain also. This data scientist now, this data analyst, what he's doing the visualizing parts by after analyzing the patterns. But data scientist, what he's doing the prediction, future prediction, getting the insight and predict the future. Okay, in his job role mainly, he has to build up the models. And what is the machine learning engineer? What he's doing? He is doing what's that? deploying machine learning models to the production environment. His main task is deploying machine learning model to the production environment. So after that, scaling and optimizing the model. Scaling and optimizing model. He has to do the optimizing part of that one. And he has to monitor the deployed model, whether it is well trained or whether it is generalizing the things properly. Okay, those things he has to know. So he should have good mathematics knowledge and also the Java, Python, Scala, those type of things. At least I told the Python knowledge you should have. Knowledge related to distributed systems, model and model evaluation, learning algorithms. You should have this knowledge. Okay, those are the things. Okay, and I have compared the things here. Okay, according to this way, you can just go through this one because I have uploaded this presentation to the group. You can go through that one. What are the skills levels you should have? Okay, those are the things I want to discuss you guys today. And the next day, very important day, guys, I will be explaining a project step by step, and also you guys should ready with your laptops. Okay, because I will start from very basic level and getting a data set, then extract the features, and after that we are building up the model. Okay, so very interesting thing. Even if you are having a low level Python knowledge, that's okay. I will explain everything. Those are the things. Okay, now the next day onwards we will be moving to the practical things. Share this knowledge to your guys. Okay, share this thing in your communities and explain. I will sacrifice my time for you guys because I think you understood the things. How about the day, guys? Is that cool? Are you there?
Yeah.
Okay. Then we'll meet up the next day. Thank you very much, guys.
Yeah, thank you so much.